Heyo, we're back. We're going to try something a little different this time. We'll just hang out here and see what we can get done on writing a minimal assembler for the EUP5108, so we don't have to hand compile all the time and constantly refer back to this thing, the assembly grid. Actually, there's some changes in the assembly language. It turns out I had duplicated a number of mnemonics. The LAI, LBI, I changed these over to LAM and LBM and such. And these would be load into the A register from memory, pointed to with the DR register, and the like. So, feel free to hang out, ask questions. We'll pretty much just be doing all the nice little background sounds most of the time. I can't stand hearing myself in my ear, so I'm going to get rid of that. Hello. Okay, looks like it's still working. Alright, let's see how this is doing. Looks okay. We're going to open the chat window here. There we go. All right, ready to rock and roll. So, in order to write an assembler to convert, well, the primary purpose of an assembler is to convert the 3-letter mnemonics into binary opcodes while keeping track of where they're going to be in memory, and then to be able to do things like define variable names, give them an address in memory, have that automatically assigned so I don't have to keep track of it, and so forth. So obviously the first thing you're going to need is the ability to add comments. So we're going to use hashtag or hash brown as our comment character, and ignores everything to the end of the line. And then we're going to need the ability to bring in other files, kind of like the pound include in C. So that will be to keep it minimal and easy to parse, we're going to use a bunch of single character commands. So file name would include that file at that point, much like you do in C. We're going to write this in C on the desktop because it's just much more straightforward, and that's how most embedded systems operate right now. You write your code on a Windows machine or a Linux machine, you compile it, and then you download it to the target in some way. Often it's over a serial port or TFTP or something like that. Or you put it on an EEPROM or a memory card, you stick it in a machine. So let's see. Include files, provide numeric constants. So if it's a hex constant, it'll have a little x in front of it. If it's a numeric constant of the size of 1 character or 1 byte, it will be a C. If it's 2 bytes, it'll be an S. Let's see what else we got here. We want to be able to set the origin or the start point of the assembler's program address. So we're going to do that with the O command. And then there's going to be an assembler's data address, which is where which directs it where to put the variables in memory. And that can be oriented with the capital V. And so to write any number of bytes starting at the current location, incrementing it as it goes, we can write literals. And this is so that we can deal with things like binary literals at the top of the program that are the reset vectors and the interrupt vectors and the like. And then also we want to be able to write strings directly in without having to convert each character. And then we will have something like the pound define in C++, where we define a constant name, and then everywhere else in the where it comes across that name, it replaces it. So to assign names to a memory location in RAM, we'll have the little lowercase v, and looks like we had an overlap here. Well, let's see, defined. We will have case sensitivity over these characters because that'll be much more straightforward. So set the assembler's data address. What do we want to do with that? Maybe an A. Let's make that an A. And then let's see. That way we use those. And for V for defining it. And then obviously the next thing it's going to have to do is have a lookup table of all of the mnemonics. Be able to quickly find the mnemonic and replace it with the opcode. And then also know how many instructions are expected for an opcode. Or how many bytes are taken up by an instruction for a given opcode. And anything greater than 1 means it needs to have a parameter. So if the parameter is not there, we can burp on the assembler. And so the basic process is we're going to have a 2-pass assembler. The first pass is going to go through process only the includes and the define and origin commands to sort of build up a table of all the labels. And then the second pass will process the commands ignoring the define and origin. Well, I guess not the origin. We'll need ignoring the D commands, but then substituting the various things we've defined. So that should create a, let's see, let's go ahead and set the language. So this would be sort of an example assembly file of what we're looking for. So this is write the value of the label main in the first 2 bytes. So main is going to be our main function, just like in C. And so this is really just a forward reference to the label main. And we're going to set our origin to 08, which will be just past the vectors. Then we're going to define a thing called a string pointer. We're going to load that so that this D string pointer should equal 8 at this point. Then we're going to stuff these bytes into ROM starting at 8. And then I'm kind of debating whether I should have this as a separate line where I put a literal 00 after to terminate the string, or if we keep it separate. We will see. Then we're going to set the program start to 0100, define print. Print will then be 0100. And this is the entirety of our print function. These 1, 2, 3, 4, 5, 6 assembly commands. And sort of by comparison, if we open up what we did before, and again with the language. So this was our loop version, which is the same 6 commands. It's just with all the comments and inline assembly or inline machine language, it's much more cluttered. So Plus, every time we added or changed a thing, we had to, hand increment all of these memory locations. So the assembler is going to take care of that for us now, or eventually. Let's see. So that's our entire print function. It's going to be this sort of assumption that it's going to be a function call and not a goto, because gotos are mean and bad. So this does the same thing, loads the first byte pointed to by the DR register, and if it's not 0, then we write it out to the port, increment the DR register, and jump back to print. And then if it is 0, this will fall through, and then we'll return from the function. So that's our print function, all 6 bytes, or all 6 instructions rather. And then here we've defined main, which we referenced up here. This is why I'm going to do it in a 2-pass. It's just easier. So first thing main does is load up string pointer into the DR register. String pointer should be 008 or 0008. And then it calls the print function itself, which is here, and then we halt. So this is sort of the assembler style and syntax that I want my assembler to be able to handle. Nothing terribly complicated just yet. No manipulation or mathematics within the assembler. One of the options, though, would be to go ahead and pass my assembly files through the C preprocessor, and the C preprocessor would handle all the pound includes. It would have its own macros and all that kind of thing, all these standard features that you see in using pound define and pound include. But I may just write it from scratch. For now, we're going to go with the absolute minimum and creating our own duals. So let's see, we've got that as the plan. That is our example source. And here we are. Do I have 2 copies of this open? Apparently so. We can close that because all that's over here. Yeah, it's got all my other projects going in it. So, all right, we have a plan. Let's start executing the plan. We're just going to create it as a command line app. Console app, I guess they call it. Let's just keep it in C++. There we go. So the Microsoft assembler is called MASM. I guess we could call it EASM. YASM. Might as well call it YUPASM. YUPASM. That doesn't sound strange at all. Put everything in the same folder. Now we're going to see if my, whoops. See if we can get this to fit in the window. All right, let's see. I have to do string manipulation. I always like standard IO and string on most of these. Not really going to use C++ because it's kind of overkill, really. Let's see. Real quick, we're going to test if my mute pedal causes Visual Studio to do anything. And it causes it to rebuild. Whatever. That's good enough. A convenient build button too. Alright. Let's see. It's under keyboard. Hotkey, where are you? We'll fix it later if it gets to be annoying. Alright. So let's see. We're going to definitely need normal. In case there's some path given. Alright, open the file. What do we want to first do? So we're going to have two passes. Let's make a function called pass1. We're going to pass it the open file handle. So it's going to be I guess that should be it. Yeah. Might return an error. So to process the file, we're going to have to do the following. Read file. Confer, include, define, and origin commands. Oh, I guess I should set up the pointers that we're going to use as well. It could be should only be one character long, but we'll see. I don't remember the string toke function all that well offhand, so it might be a character pointer or something, but anyway, should only need to be one character. Let's do the defines. program looks like. So it'd be capital D and some number of characters. And if it is a D, then we're going to take and store the current APA. Yeah, that's the idea. So that's going to be stored in our symbol table. So we need a symbol table. Symbol table is going to look like basically a name value pair. We could probably use all sorts of structures and stuff, but this is not going to be that complicated. Max length for a symbol. 64. 256. Memory's cheap on the desktop. Location. This is really entry. And then our symbol table is a RN array of such. And do we want to limit the number of symbols? Just easier. I don't think we're going to run into too many too fast, so we'll keep 1K worth of symbols. If we eventually get to big assembly programs, I might need to change, but for now it's okay. Oh, not quite the right syntax here. Alright. And then let's see. Some level of verbosity. Exactness. Let's blanket. actually. That's a little better. We'll keep it simple. We're not expecting a white space. So the line should start with the character and have space. Oh, we should really throw away comments first. And we should track the line number we're processing, so when we have an error, we can tell people. Tell me. Okay, this one. Really, there's nothing to do. If the command equals that. If there's nothing to do, there's nothing to do. Yeah, I haven't put this in the loop yet, so maybe a break. Maybe. didn't take me there. Edit advanced information. Just does the one. Let's see. Yeah. It's not useful. There we go. Yeah, it's better. Read line. Yeah, do it character by character. Whatever. Yeah. My mute button also builds. Whatever. Alright. Read line. just do it one at a time. It's going to return the number of characters read, or the length of the line, I guess. We'll read a character at a time, so let's check if it is. We're going to stop at the hashtag, or we're going to stop carriage return. New line. I'd like to see. We're on Windows, so there's carriage return line feed instead of just line feed like Linux. So we have to check for the first one and then throw away the second one. So handle these separately. So if we get to a comment, we are done copying. So we can just turn the character count. Else. If I should say else if frames. Dang it. Yeah, it's not much. Let's see. It's carriage return line feed. There, that should come first. So, carriage return. Oops. It's not a character. We have to throw away the next. Dang it. Can't just return from the comment. Have to continue. Let's just make a flag that we hit a comment character. We want to get through the entire line so that the next call through here is on the fresh line. We have to throw away all the characters, so we'll just flag it. And let's see how that's going to work. At some point we're going to have to increment car count. Also check for if we read past the end of the file. So is trying going to be EUF? Yeah. Let's do it that way. Guess it could be a character at the end of the file, but it's unlikely. Yeah, we'll put this above. I suppose these don't need the else here because we're in the comment. copy the carriage return anyway. So that all does that. Once we copy it, increment the counter count, and then if everything, there's the return in the character end. So shouldn't be any alternate paths. Let's see what the compiler thinks. Yes, he is. Illegal break. And we'll get to that. Anyway, I didn't like any. I didn't burp on this function. Alright. Let's see how that'll work. Looks to begin with. We're gonna break later. This is printed for now. We'll include the line number. Maybe 5-ish. Most of our assembly is not going to be terribly long. So, yeah. We'll add our carriage return to it, or new line rather. Command here, and let's just see, it should read the first line out of the file. Then we'll loop this, and we should basically read and print the line, or reprint the file. Let's see, first, just the first line. Various build errors. Oh. Using unadditionalized memory. Pass 1 must return a value. Read line. Not all control paths return a value. That was my fear there. It's inside read line. We're in the file. Hello world from Yep. ASM. Well, I suppose that first line is empty because it's got a comment at the beginning of the line. So let's make it loop. And single step that should have been jumped over. Let's debug. Oof. Diagnostic tools. Need that. Autos, call stack. Sure, why not? Let's see. That's problematic because I only read the first character. So what am I missing? Alright, well, not in a file. Get character. I guess I could just loop forever. Just make this a while. That's what we need to do. Wow, we are not at the end of the file. Read a character. Check if it's a comment. If it is, we're in a comment. Check if we reach the return character. Alright. Seems more like it. And then I should also probably just for single return point, we can break from here. That'll work better. Let's see. And just go for it. Again, only wrote one line, so nothing to see. All right. Free line. So I guess same thing here. Pass one. So with luck, this will print all of the lines minus comments. And only print lines with something in them, but it throws away comments. Now if it throws away comments, our current line number. Well, we really need to increment current line number regardless of whether the line read had anything in it. Otherwise, it's not going to be accurate. So really, regardless of results or read line, and we should start at 1 instead of 0. So like the editor will understand us. Too many blings. So much crap. Yes, so that's what we were. Before we were so rudely interrupted by the blings. Alright. So now, if everything goes well, we should throw away the top 2 lines, and we should say line 3 is W main with a whole lot of white space. We should probably get rid of the trailing white space in the read line function. Let's see how she looks. There always. Well, that was disappointing. Nope. Not yet. So let's just set a breakpoint. There's a breakpoint. There's a breakpoint. Current line number is 1. Let's we'll put a fix here. Should clear current line each time. Yeah, let's see. I'll just set that at the end. And what's going weird here? Third read line is going to the end of the line. Well, this break should be hit at some point. Now let's put a breakpoint here. Line number 9. Yeah, I never do clear my end comment. End comment. I think I'd get to the end of the line now. Let's see. Do I just not get to the end of the line ever? Right. So let's see if we ever reach line 42. Get rid of this. No, we never reached that. Line windows. Carriage return 9 feed. Okay. That is my line. So carriage return line feed, another embedded headache. If you're developing an application to be nice and portable, you have to deal with the fact that on Windows you have carriage return line feed, and Linux you just have line feed, and this should be carriage return line feed, but we'll run through looking at characters. We should see this line here, example hello world ASM, and then we'll see what characters at the end of it. Don't know why that's not happening. So breakpoint here. Just look at every character as it goes by. We don't need that. All right, hash brown. We're looking down here now. Here's your turn. Now, new line comes first, because while it is carriage return line feed, they're switched. All right. So we're gonna look for new line. We're gonna double check just for checkableness. Do that. Set a breakpoint there. Make sure that we're not reading. Maybe the editor's saving it with just new lines. There's a quick way to tell. No. Usually Notepad, if it just has new lines and not character turns, it'll be all messed up. And the tabs are all messed up, but anyway. All right. Thought we were done. All right, that's gone. All right. Let's run her again. Let's, by the way, should clear the line each time. All right. Looks like my top camera is getting weak. This monitor is really warm. Should really use something other than Scotch tape. All right. Let's see. That's looking better. I don't want to throw away white space. I do want to get rid of trailing white space. We'll have to look. If we have to, we'll do it manually. But in any case. Ready, compile. We got the character. Sure enough, our file only has character turns. So we could save the file with the other line endings and see how it behaves. Because I don't want the, I want it to be universal, so I don't have to worry about it. There, it's a new line. I'll walk through it again. Oh. Reading dashes. Should be after a comment. So, because we threw it away. It's still only using one line ending. All right. Well, I guess we have new lines and no character turn. So if that's how our editor wants to play it. They actually read a null though. Let's try that again. Actually, let's make this easier. There. First line is just a comment character and nothing else. That'll make it easier to figure out what line feeds we're getting. It says Windows character turn line feed down there. I don't know why that seems to be weird. Alright, well that's the behavior we're getting. Let's just comment this out and go for it. Get some render delay. Can't stand to hear myself delayed. Yeah. Now that we shut down the window automatically. Let's see. There we go. There's some success. Line 4 contains wmain. So on. We have some blank lines, which are caused by these blank lines here. But have a length. Oh, it's got some white space. So if they're nothing but so we seem to have some blank lines here. There should be blank lines, not blurred lines. Blank lines. And let's put a blank line at the top of the file so we can check it more readily. So the very first thing it should get is a carriage return. That should be 0. Right? We're not going to be in comment. We're not going to increment. Should be. Oh, maybe we're not setting the line number back to 0 each time. Or rather, I should say the line count back to 0. So yeah. Character count 0 here. We actually need to it should be reset to 0 every time we call the function. Let's just see what's happening. So, out in the file, we immediately read in a carriage return. Carriage return, we break and return character count is 0. That should be a 0. And process pass 1, and we shouldn't have printed it. Okay. No executable code it is associated with 9. Yeah, I must have thrown it all away because I'm not really doing anything in here. At least not yet. It ignored the blank line at the beginning of the line. For some reason it's not ignoring the blank line at the end after we get something in. So we'll do a little alternation here. Blank line there. So we got blank line and immediate comment character. Then another blank line. And again, reading lines. Okay. So new line. We break and character count is 0. So we do nothing with that. Make the line number. Break out the current line. Read the next line. Character in is a comment. We are in a comment tree. Still looking for the end of line. There we go. Line we break. Character count is 0. So we do nothing. character in. Character count. What are you doing? Six, 8, 10. 6, 8, 10, etc. Lines 29 and 30. What in the world? Here, well, I used to do this for testing that. It looks like a blank line, but it's not a blank line. That kind of thing. And what we'll do is we'll put a bracket right. There you go. Still think there's some white space in there. Lines 29 and 30 have white space. Do they? They do. Make sure they're actually empty lines. Sure, 31, still 31 now. Interesting. Now 30. Wonder what that character actually is. Other than a null. Oh, what fun parsing lines. So it must be if character n was a null, it shouldn't print anything. Yeah, let's be uber verbose and print each individual character. It'll be ugly, but it should be a quick test. Do we print it as a character, or just do we want to print the actual value? Let's just print the hex value. That'll be ugly, but it should be a quick test. Huh. That's odd. It's giving us a -1. All if -1. I must not. Let's go double check the stats on what fgetc comes back with. That might be the other thing we have to do. That's interesting. I check for in the file after reading a character. Any example? Whatever. Anyway, so we're getting a -1. Probably reading it and coming back with in the file. So it reads a -1. If not in comment. And we're in -1. We do that. That ought to get rid of it. Probably don't need that now. There we go. Now we've successfully gotten rid of the excess lines at the bottom. I don't know why my editor's not giving me real carriage return line feeds, but go figure. Maybe the fgetc is processing it for me. So we get there. Now we want to trim off trailing spaces. And there's probably an existing function for that. Let's just do a quick search. Good old Stack Overflow. Eesh. Dupe. And let's just snag this. I don't know the function name, but what's it called? Tailing. Looks easy enough. Works in place. So just before we return, do we want to do it in read line? Probably. Let's do it in read line. We're not going for efficiency here, we're going for ease of coding. Ain't that beans? Now we have our simple trimmed spaces. And I think, and one thing our editor should behave for us, so we should be able to say tabs. Tab to space. That seems a little weird. Got a monospace font. Why am I in this kind of misalignment? Whatever. Not critical. Sort of tabs. Things preferences. Preferences language. Should be. That's to replace with settings. Just messing up again. Close enough. Weird. Weird. Lined up there. I don't know. Don't know why that is. Whatever. Moving on. Something with the language set up in the editor. Close enough. So we parse it all out. Now we want to, since we're on the first pass, we want to use these defines and origins. We have to find an O. If we find an O, we need to parse this next symbol and do the conversion. ATOL, as it were. I guess it's ATOS. All right. Let's get down here and there. Don't have to worry about the comment character anymore. The O command. Command should always be the first character in the line. We'll make that a requirement. Not worry about white space, front loaded white space, whatever you want to call it. So let's just say CMD. Line. We should be able to, let's see, we want to read in a value. So let's is going to be the parameter. Sign short. Then it's balance entry, param val equals 0. And let's see. Is it ATOS? I believe. Oh, come on, little thingy. I'm going to have to print a bracket. You're going to have to print a bracket. I guess it's going to be ATOI. Standard lib, so I guess we'll just use that. And that should be the rest of it. So line to the first character. No. And this is the current line to the first character. Alright. So for verbosity, we will let's just print it. What the hell? More with the printing. Let's see. CMD equals O, not O, O. I don't have it in quotes. Saving me from my coughing fits. Hope you all appreciate that. Wow, 2 hours so far. That's crazy balls. Well, we're probably going to cut this off when we get hungry for lunch. Maybe we'll come back. Maybe not. We'll see. Okay, so we printed out. Let's go ahead and make sure we get a new line in there so it's not all annoying. So that should print all our commands out. Errors. Expected a semicolon. Of course you did. Okay. I'm gonna mention this once, but probably the biggest dick move you can do is to go into somebody's code and find a line that's not supposed to end in a semicolon, like this one. Go way out here. Give it a semicolon. Right? So, semicolon, hidden from view. Go ahead and build it. Well, now you're like, what in the world? Why is it not doing anything? I'm not doing nothing. What's the problem here? So, oh, hey, wait a second. Ah, wasn't that nice of them? The compiler or the editor fixed it for you. Well, that's nice. That used to be a real pain in the ass. People screwing with each other's code. All right. Move it on. All right. So we're reading 0. Probably because X blah 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 don't mean anything. So let's just use the standard C format. So I'm not really reading this character by character that I originally imagined I would. So if we put a 0x in front of that one, in front of that one, it should behave. I think it will behave. Nope. I forget how to deal with. Anybody know what the function is to parse a hex string in C? How's that the one? So, all right. STOI A16. STOI is undefined. STOI. Standard template library stuff. Yeah, we don't want to use it. Let's see what the other one is. That's the one I'm used to. strtol. String too long. And we're just going to insist that you provide it in hexadecimal. Or I suppose we could check. Let's just see. There we go. That behaves. 8, 256. Works well enough. Let's see if we can get rid of the 0x in the source. Nope. Nope. Burped without the 0x prefix. Odd. I'm telling it, space 16 right there. Alright, well, that'll be the new rule. Got to use 0x to designate hex numbers. Alright, so those parse correctly. I don't really have a way of knowing if you typed in something bogus and it came back to 0, but I guess the processing will tell you. Or the behavior will tell you. Don't need to print those anymore. And instead what we want to do is every time that happens, we want to set the we're pretty much done with read line right now too. So we want to set the APA. Alright. That's the simple part of it. Now we're going to define a symbol, and now we're going to have to deal with leading spaces. So let's go snag a leading spaces function while we're at it. There's a standard set of them. I don't want to use all that C++ oriented crud. Really, I just want to adjust the current line pointer. So basically just adjust this. Pick it. If it is white space. Yeah, we can do that in read line as well. So that's trim trailing spaces, right? And then Do there. Because it's find first non-white space. I guess it'd be the thing I'm looking for. Let's just return that. Oh, space is white space. I suppose I could just tokenize the whole string and then I'd have a list of tokens, but I'm not necessarily in the mood to do it the easy way. So while it is that, let us increment the return value. Oop. Might be easier to tokenize it. Oh, I guess I should have a current symbol in my symbol table. Current symbol or next symbol? Next symbol. Into symbol table indexed to the next symbol. Symbol name is the destination and source. Yeah, I suppose we should use string toke. And string type will get rid of the leading spaces for us. Because I have to. No, I don't think I have to actually. Because the symbol doesn't have a value. The value is already in the current APA. So it's all just going to be the next character, or the next. Yeah, I don't need to tokenize it because there's only one parameter. That's my point. I love Control Z. And then this is going to be correct line. Address def find first not white space in the current line. And it's string copy, so it's nice and unbounded and could go off in the weeds, but who cares? Copy all over the cable, and then we also send table to the next symbol. Yes, we could use a binary tree for simple tables, and that would make the lookups a lot faster, and so on and so forth, but we can do linear searches when there's not that many. Again, efficiency is not my concern right now. I got a big old fast computer. There we go. Auto formatting, whatever. Alright. Put brackets around a symbol so we can see it. Or maybe we put quotes around it. Not quotes, but single quotes. Good run. my little pretty. What we got? Symbol 0 is D Strimpif. Well, that's not right. You see, that's not correct, isn't it? It's because we didn't start one more into it. Suppose we could delete the D. Let's delete the D. Again, we're not worried about efficiency here. So command equals D. Let's make this a character pointer. Reference equals and we just use a current line and say CMD and then use CMD there, CMD there, and that should behave. Just put a comment here. Get past the command letter. There we go. Sure enough, symbol 0 is, and of course we forgot to increment the symbol number. So we stuffed them all in the same one. Minor glitch. Plus plus. There we go. 0, 1, 2, 3. I don't have functions yet, so I don't have like scoping of symbols. So we're gonna have to sort of fakey the scope, and we can actually do that like they did in the old days, since much of what we're doing is like they did in the old days. Let's get back around to the program. And let's see, this is sort of a locally scoped symbol, so let's call it print.m, because it doesn't need to be very long. And this will be, and if we do that, then it's scoped by format, not by actual scoping, but then because here the functions are global symbols as well, so this is a global symbol, but by using this pattern we know it's meant to be a local symbol. Should behave plain. Fair enough. Printf symbol 2 is print.in, and that equals 100. It shouldn't, well, it equals 100 because we haven't gone through parsing the instructions and increasing the instructions yet. That is actually a long and boring task that I still have to do, which is finish filling out the table that converts instructions to opcode, the size of those instructions. Anything more than one is there's a parameter expected, and then also the number of cycles for each instruction. I'm not going to really use that yet, but anyway, let's see. Yeah, so it's going to take a while to fill this out. I had made an initial mistake. You'll notice there's 2 LBIs and there were 2 LAIs. So the second LAI is going to be LBI and LBM for read into B from memory. It was originally meant to be indirect, which based off the pointer, but anyway, had a name collision there. We got to finish fixing all that up and filling out this table. I doubt anybody wants to watch me do that. So let's see. About as far as we get for now. I think so. Our symbol table's looking good. Let's go ahead and remove those comments. And then, so we're handling the origin function and we're handling the symbol, the define function. All right. And that out for now, and then maybe we do a symbol dump, table dump at the end here. So let's just actually let's take those lines out. We'll turn this on or off later, but for now, let's say quotes. Let's just, yeah. Do we have the header in the function, or do we just have? Let's see. Symbol table. It'll be in the order they're found, not in sort or anything. We'll have a symbol table function. Note the massive use of globals because it's easy. So, sim table. All right, so remember, the title includes minimal, which means we're not doing all the checks we should. This isn't safety critical software or anything like that. And then this would be our print command that we had earlier. since it is the symbol table, we don't need to include the word symbol. I'm going to do them in a different order. The quotes around the symbol, just to make sure we ain't got any weird white space there. And yeah, that looks good. Do we need symbol number? Yeah, might as well. So we're going to have percent. What do you got? 4D colon. So symbol number, symbol name, symbol value. Just make it to where it be a good comma delimited list. If we ever needed it as a comma delimited values. So this is the next symbol. Is I, as is that and that. So that looks good. There we go. Symbol table. We have to get the values going correctly. Why do I seem to have white space in front of it? Oh, because I told it to print 4 so that they were nicely aligned. And then yeah, I don't like the alignment here. Let's cheat and use tabs or rearrange it. Symbol 0 value. Number name, number value name. That's what we'll do. So we want number value number value name. There we go. Number value name. Maybe here we print symbols, symbol table, and then num value name. There we go. Keep it all nicely aligned. All right. Now we got to start a symbol table. See. I'm not going to operate on an array of bytes that is my binary file, or am I going to write my binary file as I go during the second pass? Might be easier to have it internally. Again, I got crap loads of memory. Hell, my program can't be more than 65K in size anyway. So we might as well process it into a 65K buffer, and then that way I can sort of dump it out in hex rather than having to look at it in a hex editor. And then obviously we can dump it out at the end just as a dumping of the, I think we'll probably do it that way. Let's see, we're coming up on lunch actually, but we're coming up on 3 hours, and it's probably a good long length of a stream. Getting an average view at 10-ish minutes. That's pretty good. Let's see. What else do we want to do? Well, let's go ahead and make our program buffer here. Is that find first word? First not white space. We're still working on pass 1. Pass 1 does not produce any output other than warnings and building up the symbol table. So let's see. We'll just have a big block called the output program. Let's see, and it's going to be a bunch of unsigned characters. Unsigned character, otherwise known as bytes. And we're going to call this the program ROM. And it is 65.5 36 in size. That's 16 bits, right? 16 bits. X. Now 65.535. The 0 is the 620. There's our program ROM in memory. And we should probably blank that. Well, can I just blank it? Can I blank it with the curly braces? Like so. Let's see if it likes that. Doesn't bitch. Probably worked. We got our name, and then so the next things we'll do is we want to do a print of our program ROM, and we want it to be reasonably readable. So we'll do the whole 16 characters wide in hex, probably with spaces between them, and then 16 characters in printable characters on the side. And well, we'll come back to that. I am beginning to get a little bit peckish. So thanks for all of you who hung out for me while we're doing this. Maybe we'll come back this afternoon. It might be tomorrow. Like I said, I don't think anyone's really interested in watching me fill out this table. But this is what's going to be drawn into another large structure. And hopefully I can just sort of massage the text instead of having to do any major conversion. So let's go ahead and, in the little time we have left, let's go ahead and create the structure that these are going to be stored in. Now, they're nicely alphabetized here, and that is because with that I can do a quick binary search over the sorted data. And you know, when I say I get LB, well, LBH is the command. I can basically have a start and an end pointer on the array, and start in the middle of the array and say, is this string less than or greater than If it's less than, then I can cut the array in half, just with pointers, of course, and then pick the midpoint of that, and basically half step my way into finding which symbol I'm looking at. And should only take, let's see, it's going to be log in instead of order in. Since I'm just storing the symbol table unsorted, that's going to be order in. You know, the bigger the table grows, the longer it takes to find, on average, a symbol. This should keep it from growing too particularly large and being at least a small, reasonable attempt at efficiency. So I'll probably spend the rest of tonight filling this out and getting that all set up. So let's go ahead and create the structure anyway. So it's a 3-letter 4 with the null. So 4-letter string, byte, a byte, and a byte. That'd be 4, 5, 6, 7. I don't think any of them take more than, yeah, none of them take all that many cycles. So yeah. Alright. 4, 1, 1, 1. Go ahead and create that structure. If you like what you're seeing so far, please like and subscribe and all that fun stuff as I've been scrolling across the bottom of the screen telling you. And that way, if this gets some traction, we'll do some more. If not, we haven't had much in the way of questions. And by that, I mean we have had 0 questions. So if we get some traction with this, we'll keep doing it. If not, we'll stop. That's how this works. So that's how these experiments work. Alrighty, let's see. Sure, that's our symbol table empty. Let's go ahead and create. We can create a program ROM. Let's create a. What are we going to call this? Instruction matrix, I suppose. Instruction matrix. And this is going to be an entry to the instruction matrix, which consists of characters for long. Give it a name, right? This is the mnemonic, so we'll call it the MNO for mnemonic. Then we'll have a unsigned character for the opcode. And we know exactly how many we have of this. And hopefully I will be able to just copy that spreadsheet into this set of curly braces. But for now, we're going to make it all equal to 0. Good place to start, I suppose. Let's just make sure we didn't burp on any of that. Are we still debugging? Let's stop debugging. Yep. Came up, didn't complain. All right. Well, we'll come back to it after that. Thanks for hanging out. Hope you had fun. Maybe you learned something. Maybe you didn't. And we will be seeing you next time, I guess. Thanks.